Welcome to the Rich Report, a podcast with news and information on the world of HPC. Today my guest is from SGI. We have Bill Mannel. He's the VP of Product Management. Bill, welcome to the show today.
Oh, thanks, Rich. I'm glad to be here.
Well, it's great to have you back on, Bill. And I thought, we missed you guys at ISC, so I thought it'd be good to get an update on what's going on at SGI. So your slides are up. Why don't we start there?
Sure. So I'd love to give you an update on our HPC solutions right now. So if you go to slide 2, we've continued our focus on speed and scale. We coined the term finding answers at SC12 last year, and that's what we're about for our customers and for the world at large. We work from the subatomic level all the way up to the astronomical level, and we've got customers that are doing work in all areas in between, from designing new planes to doing astrophysics work to figuring out things on a subatomic scale. So on slide 3, want to talk about a couple platforms that we have and some progress and some news on those. So first of all, we'll talk about the SGI UV platform and then the SGI IceX platform. And these platforms are both platforms that are great at HPC workloads. We also do sell the UV platform into big data workloads, things like fraud analysis and those sorts of things as well. But I'm going to focus on the HPC side for this particular presentation. So on slide 4, you and I, Rich, talked about the UV2 being the big brain computer at Hamburg last year, and it continues to be a very important horse in our HPC stable. It really allows no limit computing. So someone who wants to use large amounts of memory, large numbers of processors, and be able to manage it easily without having to worry about lots of individual nodes and networking switches and those sorts of things. It's a very convenient platform for them. Now, it is the largest in-memory system, so it supports up to 64 terabytes in a single system image, and it's all built on open components. So between x86 processors, Linux, and open libraries and compilers, it provides a great resource for customers. The next slide, slide 5, shows a little bit of what it's about. So it basically allows you to up-level yourself above having to manage commodity clusters. We call it a big workstation. So it actually looks and feels like a workstation, has a single copy of the operating system, but it has no limits over the normal workstation. And it looks a lot like an enterprise SMP type of machine, but it's squarely in the Linux and HPC and open environments as well. Now, one of the big trends we've seen is on slide 6, and we've seen a lot of interest in a lot of new and interesting places, especially around financial services, where a lot of folks are doing their own internal code development. So they're creating their own algorithms specifically to their businesses in terms of what they do. And they've really seen an interest in the UV because, first of all, it's open source, and they like that feeling of security and safety around open source. They're doing a lot of analytics work on it, so things like using R and Neo4j for graph analysis. And because of the Linux and the KVM virtualization, they can actually build it and use it in a workgroup development. So with KVM providing a variety of security and isolation between different programmers, different work groups, they can now work on a number of projects together on the platform and not have the same cost with some of the more more common virtualization environments that are out there. So we've had, as I said, a lot of interest in customers in this algorithm development and analytics development in an open source environment. So I think that's very exciting. So for the next topic, I'd like to segue to our IceX platform. So we've had a couple of exciting things happen. First of all, two of our largest IceX platforms, Pangea and Spirit, ended up pretty high on the top 500 list. Now, one part of the news here is that unlike most of the systems in the top 10, which have some sort of accelerator or custom processor associated with them, these were both completely x86 based, so completely Xeon based platforms. Pangea is used by Total for oil exploration and production in France, based around FDR InfiniBand. Now, the interesting thing about it is that it's actually the top commercial system on the list. So if you look at everything below it, they're essentially public or government-funded type of activities. So this is really where a business has seen the value in investing pretty significantly in HPC, and Total has been a customer of ours for quite a few years. Now, they love the machine so much that you can actually go to that link that's on the slide, and Total themselves actually built just a wonderful video about Pangea, their new IceX machine. So certainly spend some time going through that. That's available on the SGI website. It actually kicks you over to YouTube. But great video, great bit of marketing for SGI on behalf of one of our customers who did that for us. And then number 14 on the list was Spirit. This is a new machine we put in at the Air Force Research Laboratory at Wright-Patterson Air Force Base in Ohio. And again, standard technology, Xeon with FDR InfiniBand. So we're very happy about those two entries into that list this year. Now, both of these, if you go to the next slide, both of these use the M-Cell. So the M-Cell is a self-contained cooling environment that allows customers to get very, very good price performance per watt. So really drops the power. Essentially a closed loop design. It supports warm water cooling as well. So that takes a lot of the complexity of a data center out, and has been the basis for these two large machines for us. Now, if you look at the next slide, out of this last June list, we actually sliced and diced it a little bit, and what we find is that the Total machine again machines based on standard Xeon technology actually has the best megaflops per watt, or basically price performance per watt of all the, or I should say performance per watt of all the Xeon-based machines there. So we're very happy with that, and that's we attribute that to a lot of the design work we went into the M-Cell. Now, in addition to the M-Cell, the next slide, we also offer other types of configurations. We have a standard D-rack at less density, but it does fit into a standard front-to-back airflow type of environment. You can add water-cooled doors on the back of that, radiators to help with the cooling as well. Not quite as efficient as the M-Cell, but for those who want a traditional data center type setup, they can use that. For large-scale HPC, again, the M-Cell is what is the configuration of choice. And then finally, we're talking with a number of customers about using this M-Cell technology in a container type environment as well. So that's exciting to us too, as customers look at using our container products as opposed to standard type hard wall data centers. And just as a little bit of a summary of this IceX product, again, this was what both Pangea and Spirit are based around. We have a twin node compute blade in that, independently scalable power infrastructure that allows us to optimize the number of power supplies across the system while at the same time getting the right amount of power as well as redundancy in the system. It has a number of different cooling solutions, of which the M cell is probably the most interesting. It's a unified backplane fabric based around InfiniBand FDR. It has great density, and again, as we saw on the previous slide, supports a whole bunch of different data center environments, from containers through self-enclosed M cell environments all the way to standard D cell. Standard 19-inch rack type environments. Now, the other news that we have is in the same architecture that we deployed Pangea and Spirit on, we're now adding the Xeon Phi coprocessor into the mix, and so essentially we have a new blade that's on the next slide called the IP119. And it's actually a sandwich blade like our blades that we've done that are exclusively Xeon, but we've actually replaced a couple of the Xeons with the Intel Xeon Phi 5120D SKU. So this particular SKU is the D is meant for dense, so it's meant for dense environment. So we basically essentially cut off the back end of our standard Xeon blades and plugged in one each of these 5120D Xeon Phis into it, and using the same cold sink architecture and M cell capability as we have in our other machines, we're able to cool that and provide pretty phenomenal densities. I think it's 170. If I remember correctly, it's 172 teraflops a rack. So that's pretty phenomenal. That is peak from that standpoint. And if you look at the next slide, a little more detail. This actually shows these blades that we have for the Xeon Phi. It's a sandwich blade, just like our exclusive Xeon blades. And you can see the spots where the Xeon Phi would be located here. That's down in the foreground, and then in the background is the other half of the standard Xeon piece of each of the motherboards. And we call it a sandwich design. It's two halves that fold over with cold sinks in between. The next slide actually gives a little more detail on the motherboard itself, and basically it has a PCI. If you look on the right side of the diagram, has a PCI connector there that allows you to plug that Intel Xeon Phi card right into the motherboard. And we did some work early with Intel to make sure that worked. So we do have some technology that we helped Intel develop to make sure it fit well into our platform. I won't go into slide 16, but if you look at, or if slide 15, I'll look at slide 16. Again, this is the whole thing together with the two sandwich blades apart, or I should say the two sandwiches together as a sandwich. And at the back end on the right, there is a mezzanine card that fits there to bring in the FDR InfiniBand. And then the last slide here is a little more detailed view of, you can see the two motherboards in this case, and that cutout there is where the InfiniBand HCA would fit to allow you to plug the blade into the InfiniBand fabric.
Yeah. And is this shipping now, Bill? This solution?
It is. Yeah, we're really excited. In fact, we got a very large order that it might already be shipped, but we were building it the last time I looked a couple weeks ago. So into into the U.S. government space. So we're very happy that we got this large order to just kind of kick off the manufacturing process, and it will go general availability in July because we had this large order. We could only really accommodate one in the early going.
Yeah, yeah. So that's actually Intel was showing off. I believe that was this device at their booth at ISC, and they were very proud of how many cores you could get in such a small space. So.
Oh yeah, it was great. Yeah, I saw the video that you did with them. Actually,
yeah.
We're going to put that on our website.
Oh,
so,
good.
Thanks for that.
Yeah. So I did want to ask you about that. Some people said, well, SGI isn't here. What does that mean? Right, and I didn't put much behind it, but it was just a marketing decision that this wasn't the year to do that kind of expense, or what do you think?
It was really more about the effectiveness of actually putting a booth at the trade show. We actually had quite a number of customer meetings at a nearby hotel.
Yeah.
And actually invited customers, and that room was completely full from that standpoint.
Sure.
So again, more of a marketing efficiency type of thing. We have moved this past year onto doing a lot more smaller local events where we might have 20 or 30 people. Might feed them pizza or give them breakfast burritos. I did 4 of these over the last few weeks. One of the reasons I wasn't at the show was I was doing it with some local customers here in the LA and Albuquerque areas. And so we're kind of trying to move our show, if you will, a little closer to customers in a little bit more intimate venue. So 20, 30. Sometimes we go up to 100. We've done some what we call executive town halls, where we go up to 100. We had one in the Bay Area actually about a month ago, which was very successful. So a little bit of change in marketing strategy, trying to get a little closer to our customers.
Yeah. Well, I totally understand. And like I was telling you before we started the call, it was hot there, so.
Yeah, I understand.
We're hoping that'll be nicer next year. So Bill, as we look at this range of solutions you guys are bringing to bear here, and it's some pretty significant top 500 wins. What do you think is next for SGI? What can we look forward to?
So a couple of things. One, we're continuing to do development on our ICEX platform. We'll have new news about that platform coming up, and also on our UV platform as well. So we continue to innovate on those platforms. Our target for our ICEX platform is obviously pre-exascale moving out to exascale. So we're definitely seeing some of those opportunities, working with a few customers on some of the bigger procurements that are going on over the next few years or so.
Well, terrific. Well, Bill, I want to thank you once again for coming on the show today.
All right. Thanks a lot, Rich. I enjoyed it.
All right, folks. That's it for the Rich Report. Stay tuned for more news and information on high-performance computing.